Hello class, today we are trying to understand what happens when we multiply fractions. So I want to start by reviewing what does multiplication mean, and this is something that we've looked at in the context of integers in our math careers. And we know that one way of interpreting multiplication is the groups of definition. In that definition, our first factor in our multiplication is telling me how many groups that I'm doing. So in this question, 2 times 3, I could interpret that 2 as being 2 groups. And then our second number is telling me what's in each of those two groups. So in this case, because my second number is positive 3, I'd say that I have two groups of 3 positive tiles in each group. So if I went ahead and drew one group of 3 positive tiles, 1, 2, 3, I'd then need a second group of positive tiles, 1, 2, 3. Now my product is going to be the total. And so I want to go ahead and say, well, overall, how many tiles do I have across all of my groups? And of course, in this case, I have 6 positive tiles. And so I can say that my product is positive 6. Nice elementary school example. Take us back to the good old days. Now in integers, we also deal with what happens if we have a negative second integer, and we can interpret it the same way. We still have two groups from our first factor, but in this case, there's 3 negative tiles in each group. And so, of course, we're going to say, well, here's one group of 3 negatives. Here's a second group of 3 negatives. And in total, what do we have? Altogether, we have 6 negative tiles. And we therefore could say that our product is negative 6. Now, in any problem where we do have that whole number as our first factor, we can use that groups of definition, and that applies to fraction multiplication as well. So let's take a look at these examples where we have a whole number times a fraction. So in this case, we have 2 times 3/5. And in this case, right, we are very similar to our 2 times 3 positives, right? Our 2 is telling us that we have 2 groups. Our 3 is telling us the amount of tiles. And just like up here, the sign told us if they're positive or negative. Here, the denominator is telling me what type of tiles I have. So since I have a denominator of 5, these are going to be fifths. Whoops. Where are we? Oh, goodness. Fifths. There we go. So let's go ahead and think about that. I'm going to set myself up 2 groups. Oops, I guess the second group should probably be group 2. And inside of each of those, I need 3/5. So I'm going to start by drawing one hole. If I drew in and colored in that entire rectangle, I'd have one hole. I don't want one hole, I want 3/5. So let's start by making fifths. That means I'm going to divide up my one hole into 5 equal parts. And same for this one hole, 5 equal parts. And then how many of those parts do I have in each of these? Well, 3 of them. So I have 1, 2, 2, 3. And in this one, I got 1, 2, 3 down here as well. Okay, so I'm just going to match my coloring here. 3 is telling me how many pieces. The 5th is telling me what type of pieces. Just like before, my product is going to be the total. So I want to count up how many pieces I have in total. I see 1, 2, 3, 4, 5, 6 total pieces here. And then I want to think about what type of piece each of those are. Each of those is 1/5 of the whole, 1 out of 5 parts of a whole. So I can say in total there are 6/5. And that tells me that I can write my product as 6/5. If we look at our second example, in this case, we have our 2 as our 2 groups again. Okay, the number of pieces that we have in each of those groups is 5. And what type of piece are each of those pieces? They're thirds of one whole. Let's go ahead and set up our 2 groups. Group 1, group 2. Here's group 1. Here's group 2. Beautiful groups there. And I need to get 5/3. Now, if I draw one hole and I split that up into 3 pieces, that gives me at most 1, 2, 3/3. But I need 5/3, so I'm going to go ahead and draw a second hole. Split that into thirds as well. And then I've already got 3, so 4, 5/3 in the first group. The same thing in the second group. Thirds. And in that second group, I need a total of 5 thirds as well. So 1/3, 2 thirds, 3 thirds, 4 thirds, 5 thirds. And in our product, we want to count the total. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what type is each of those pieces that I have? They're all thirds of one whole. And I can, of course, say that this product is 10 thirds. All right. Now, if our first number is a fraction, right, a fraction is part of something. So we can still think about this idea of groups, but if we have that fraction, it means that we don't have full groups of that second factor. We'll have part or parts of one group of that. Now you want to remember what you have here is the second number you can interpret as what you have at the start, and then the first number is what you're keeping from that. How many parts of that are you keeping? So if we take a look at this fraction times whole example, we have 3/4 times 8. And we want to interpret that 3 here as 3 out of, for that fraction, every 4 parts. And then what our second number is what we had at the start. So we had 8 wholes to begin with. Okay, so let's go ahead and draw 8 wholes. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful drawings. And, oh goodness, when we moved, really having trouble with this tablet today. That's better. Let's try that again. Maybe make them a bit neater this time. I can think of having all 8 of these at the start. Now, I only want to keep 3 out of every 4 parts of those. So let's break them up into 4 parts each, or fourths. Quarters would be another word you could use. And I only want to keep 3 out of every 4. So I'll keep 1, 2, 3 in that one out of the 4. 1, 2, 3 of that one out of the 4. 1, 2, 3 out of that one. 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 And 3 out of that one as well. So I had 8 wholes to begin with, but I'm only keeping 3 out of every 4 parts of those. So let's try to count up how many parts we have for our product in total. Remember, we're only doing the ones that we're keeping. So we're going to keep 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And we want to think about what size each of those parts is out of one whole. Keep in mind, each of these rectangles is one whole, and each of those parts is a fourth of one whole. We can say that 3/4 times 8 is, how many parts do we have? 24. What size is each of those parts? It's a fourth. Of course, 24 divided by 4 can simplify down to 8. And if you arrange these parts into filling up each hole, you would end up with, 6, obviously. You would end up with 6 fully filled in rectangles, okay? Now we can apply the idea to fraction times fraction. This one in and of itself, I mean, 3/4 of 8, you could just do 8 times 3/4, get that same answer. Okay, but this one here helps us, or that idea of parts of helps us understand this one here. So if we take a look at our 1/2 times our 3/5, we can go ahead and interpret this as we're keeping 1 out of every 2 parts. And what do we have at the start? Well, all we have at the start is 3/5. Okay, so let's think about what we have at the start, this 3/5. We need one whole to represent 3/5. I'm going to break that whole up into 5 parts. Could have been a little bit more equal, but there we go, kind of. And of those, I only have 3 of them. 3/5 are shaded in at the start. I guess I could use green for that to match my coloring. Three-fifths. Okay. Now, I only want to keep 1 out of every 2 parts of that. So I'm going to go ahead and I'm going to divide this up into 2 parts. I only want to keep 1 out of those 2 parts. So I'm going to choose to keep the top part and not the bottom part. So I'm going to go ahead and say, well, I can keep whatever is represented in this top part of the diagram. Okay. So how many pieces do I have? 1, 2, 3 pieces, because remember I only had the green to begin with. I'm only keeping the blue parts of those. So how many boxes shaded in? I have 3. Now, how many total boxes are in the rectangle now? Remember, the bottom of a fraction tells us how many total parts make one whole. So if we're counting each of those as a part, we had our 1, 2, 3 parts. 4, 5, 6, 7, 8, 9, 10 parts are in total in this rectangle. So we can say that our product is going to be 3 pieces. Each piece is a 1/10, so 3/10 would be our product. Okay? So I hope that's helped you a little bit with understanding your fraction multiplication by linking it to some of those ideas that we've already dealt with in other concepts. And we want to use this to develop our ability to multiply these symbolically. But it's helpful to think about this context of groups and keeping parts of objects to help understand why those symbolic rows work. Anyways, hope that's helped.